Over the last 109 years, aviation has made leaps and bounds since the historic Wright brothers flight at Kitty Hawk, North Carolina. We have evolved from slow wooden frame aircraft to propeller-driven aircraft to jet engine aircraft. We even have an aircraft now that's called a scramjet that's capable of traveling Mach 7. But the success of these aircraft have revolved around two rules of lift. These are known as Bernoulli lift and reaction lift, and they are the reasons aircraft are capable of flight. So, what is Bernoulli lift? Well, Bernoulli lift is Bernoulli's principle as pertained to flight. And the U.S. Sentinel Flight Commission defines Bernoulli's principle as the pressure of a fluid decreases as the speed of a fluid increases. So what's this mean for aircraft flight? Here we have a basic side view of a wing. Bottom is flat, top has a curve to it. Now this curve forces air as it comes across the top to accelerate. Accelerated air means drop in pressure. So more pressure on the bottom than the top equals lift. Now, what's reaction lift? Mr. Johnson, who is a physicist at the University of Chicago, defines reaction lift as the effect of the pressure of moving fluid, or in this case air, against the bottom of a tilted surface. So, what's this mean for flight? Here we have a tilted wing surface. Now, reaction lift is based on Newton's third law, which states every action has an equal and opposite reaction. So air hits the bottom of the wing and is forced down. And based on Newton's third law, reaction lift says the wing has to be forced up. So that's how reaction lift works. Now, how can an aircraft use these two rules of lift to its advantage during flight? Well, it does that with primary and secondary flight controls. Primary flight controls are used to steer the aircraft during flight by deflecting air and using reaction lift. Now you have your elevators, which are on the back of the aircraft, that move up and down to affect pitch, which is nose up, nose down. You have your rudder, which is also on the back, which moves side to side, which affects yaw, which is sideways motion. And you also have your ailerons, which are on the ends of the wings, and those control roll, which is a twisting motion. Now you also have secondary flight controls. Different types of secondary flight controls, but the two basic ones that are always used and the most important are your slats and your flaps. Your slats are on the leading edge or the front of the wing, and your flaps will be on the trailing edge or the back of the wing. And so what they do is when they're extended, basically they create a cup in the wing, and that increases reaction lift in the bottom by catching more air, and it increases Bernoulli lift across the top by decreasing the volume of the top of the wing and also letting the air accelerate faster across the top. And this gives the aircraft better lift at lower speeds. So we've discussed the two rules that pertain to aircraft flight and how they work. We've also briefly discussed how an aircraft can use these rules to provide control during flight. So it's important to understand that even though flight is complicated and advanced, it really relies on two basic physics rules that have been around for hundreds of years.